Hi there. Let's take a few minutes and talk about question 15.7. These data involve the Leaning Tower of Pisa, 1975 to 1987, and these measurements indicate the number of tenths of a millimeter past 2.9 meters of lean. So in 1975, the tower was 642 tenths of a millimeter past 2.9 meters, and you can see the amount of lean is progressively increasing. That's what this linear regression is trying to measure. So once again, we have a table which summarizes our linear regression statistics. So here is the constant of the equation. Here is the slope of the equation, and I know it's the slope because it is associated with the variable year. We're not going to use any of this information over here, but once again, just to review, these are the standard deviations, or if you will, this time it's labeled the standard error of those coefficients or statistics. Here are the t-scores, and here are the associated probabilities. This time it's labeled as probability instead of p-value. Means the same thing, just as we saw in the previous question. So, first part then of this question says to plot the data and describe the direction, form, and strength of the relationship. So this is very important. This is really a description of a scatter plot. So remember, in order to generate a scatter plot, you want to go to second y equals, turn on your plot. This is the scatter plot option. I put my data into list 1 and list 2. I looked at the one variable statistics, although frankly you can just look at the table to find good minimums and maximums for x and y. So here is the window I'm using. Again, I just got these by inspecting the table that was in the book. I use these as the minimum and maximum year, and these are the minimum and maximum y values so that I can get a good graph. So here's the scatter plot. Anytime you look at a scatter plot, you should describe its direction, its form, and its shape. So the direction is clearly positive. We are rising to the right. This form is about as linear as actual data will get. So using the phrases linear or nonlinear, those are good phrases to know to use when you describe a scatter plot. So in terms of its strength, this is a relatively strong relationship because the points in the scatter plot really tightly lie along a pretty specific line. So direction positive, the form is pretty linear, and it's a relatively strong relationship. So that's what you're asked to write about in part A of the question. So again, this does not have to be a long, complicated answer. Here's my answer for A. The direction is positive, the form is linear, the relationship is strong. So fine. In part B then, you're supposed to determine what parameter gives the rate at which the tilt is increasing in tenths of a millimeter per year. That would be the slope. So again, if you look at the table, here's the slope. It's the coefficient on year. That's the slope right there, the 9.31868. So you didn't have to write the regression equation. You just have to indicate that you understand it's the slope that you're looking for. So in context, then, what that slope means, for every year that passes, so for every increase of 1 unit in a year, that's the explanatory variable, the tower tilts an additional 9.3 tenths of a millimeter. That is the change in the response variable. So it's important that you're able to write about the interpretation of slope in context. So for every 1 unit change in the explanatory variable, that's years, you have an additional 9.3 tenths of a millimeter increase in the response variable. That's really what slope means. So lastly then, in part C of the question, you were asked, we would like to determine 95% confidence interval for the tilt rate for the slope, but unfortunately we're not able to perform this inference. Why not? So the reason why we can't is an important condition of inference is not met. So this is how I wrote about it pretty simply. It involves independence. The observations are not independent of one another because they are all observations from the same tower. They're all observations from the Leaning Tower of Pisa. So one observation is in fact dependent on the next observation because the tower is continuing to progress in its tilt. They are dependent. They are not independent. That's the reason why inference, whether a hypothesis test or building a confidence interval, wouldn't be appropriate in this context.